Alright, this is Algebra 2, Unit 8, Day 9. Chose to skip Day 8 with extra material that's not required for the Regents exam, so it is something that you will learn from Mr. Kenyon in pre-calculus if you move on to that course. So today is the last of the new stuff for this unit, and it is referred to as the remainder theorem. So example 1 says find the remainder when you divide that function by x plus 2. So we're going to use long division, which means we have to add a 0 term for the squared, and we're going to divide it by x plus 2. Alright, so what do I multiply an x by? Get 2x cubed. I need a 2x squared. So when I distribute that, I get 2x cubed plus 4x squared. Subtract by changing both the signs, and we're left with negative 4x squared. Bring down the negative 8x. Okay, what do I multiply to x to make a negative 4x squared? I need a negative 4x. So we get negative 4x squared minus 8x when we distribute. Subtraction step, change both the signs. That leaves us with 0 x's. Bring down the 5. What do I multiply x by to get 0x? Multiply it by 0. So 0x plus 0. Change the signs for subtraction, and I'm left with a remainder of 5. Okay, so the quotient, we don't need to put the 0 on it, is just 2x squared minus 4x, and the remainder is 5. So if the remainder is 5, then that means x plus 2 is not a factor of f of x. And it also means, well, if it's not a factor, then we're not going to get a root out of it. So this is saying if x plus 2 were a factor of f of x, what would the root be? Well, if you had a function like x squared minus 5x plus 6, we'll say f of x, to find the roots, if you go back, way back to the quadratics, you would factor it and set each factor equal to 0. And when you solve those, that means 3 and 2 are your roots. So if you're ever told that x plus 2 is in fact a factor, then the root is merely just setting that factor equal to 0 and solving, and the root would be negative 2. Now, if you take that negative 2 and plug it into f of x, what do you get? Well, let's see, this is going to give us negative 16 plus 5, and I get a 5. So this leads to something called the remainder theorem, which is coming up, but we're going to do one more example first. But do you notice that when I did long division, I got a 5. When I plugged in a negative 2, which is the opposite of this plus 2 in my divisor, I got the same remainder as when I actually did the division. That's going to come in handy in a couple minutes. Alright, so example 2, they want us to divide, so that's what we're going to do. Lesson 8 was a shortcut to this long division. Unfortunately, the Regents sometimes makes you do this long division, so learning the shortcut is an option. They'll never ask you to do that on the Regents, but they will sometimes ask you to do this, so that's why we skip the shortcut. Alright, so what do I multiply by x to get an x cubed? I multiply an x squared. So distribute, we get x cubed minus 5x squared. Change both the signs. X cubes cancel, and I get 14x squared. Bring down the negative 37x. What do I multiply x by to get 14x squared? Positive 14x. So that gives me 14x squared minus 70x. Change the signs, combine the terms, and we're going to get 33x. Bring down the negative 165. What do I multiply by the x to get a 33x? A positive 33. So I get 33x minus 165. Subtraction step, change both the signs. The 33's cancel, and so do the 165's. So I get a remainder of 0. So the remainder equals 0. So that means x minus 5 is a factor of f of x, which means if you take that x minus 5 and set it equal to 0 and solve, you get x equals 5, which would be the root. So if you're dividing by x minus 5, the root would be a positive 5, but only if your remainder turns out to be 0. Take that and plug it into f of x. So if I take the root of 5 and plug it in, okay, roots have a y value of 0. So when I plug this x in and type it in my calculator, I'm expecting a 0, and in fact that's what I get. So on the first example, when it didn't divide in evenly, we took what we thought would be the root, the negative 2, plugged it into the function, and we got a remainder of 5, which is what we got when we did the long division. And then on example 2, we took what we thought was the root, which would be a positive 5, plugged it into the function, and we ended up with 0, which is what we got for a remainder when we did the long division. So instead of doing the long division, if you just want to know if something is a root, you just plug it into the function. If you get a 0, it's a root, and if you don't get a 0, then you would have gotten a remainder, and it's not a root at all. Okay, so that's what the remainder theorem says. When a polynomial is divided by x minus a, the remainder is the value of the polynomial evaluated at positive a. Okay, so again, because it's in the parentheses with x, it appears as if the sign changes. Note the coefficient in front of the x is 1. This is not going to work if they put any other number with the x other than 1. Because this is Algebra 2 and an introduction to this concept, they will never do that to you in this course. Higher level math might. All right, so what is the remainder when this polynomial is divided by x minus 1? You could go through and do long division, but look at that exponent. You would need every exponent from 12 on down to 0, and that makes for one really long division problem. So the short way is to use the remainder theorem. The remainder theorem says, find out what you think the root is, or what you are hypothesizing the root is. Add 1 to both sides. So we're hypothesizing that the root is 1. Well, when you plug in the 1, that would tell you what the remainder would be if we actually had gone through and done the long division. Well, I'm coming up with a negative 4. So the fact that we get a remainder of a negative 4 means that x minus 1 does not divide in there evenly. X minus 1 is not a factor. Okay. They didn't ask for that. I'm throwing that in there because they could ask it. The remainder itself was negative 4. All right, so another way to ask it. Is x minus 2 a factor of this polynomial? You don't know how to factor that one. Okay, so x minus 2, if it were a factor, that would make the root a positive 2. If we take that positive 2 and plug it in, we should get a 0 because roots happen when y's are 0. So take that hypothesized root, plug it into your function, polynomial, and see if you get a 0. Well, I'm getting a negative 6. So the answer is no. X minus 2 is not a factor. And if they say explain, then you can say because when you substitute, you do not get 0. Okay. Example 5. Is x plus 1 a factor of this? X plus 1 is a factor. Find the value of k. All right, so a little bit different. They are telling me for sure that x plus 1 is a factor. That means if x plus 1 is a factor, then negative 1 is the root. If negative 1 is the root, then if I plug it into that polynomial, I will get a 0. So that's what we're going to do. We're going to plug it in for x. But now I'm not trying to see if I get a 0. I know I'm going to get a 0 because it's a factor. So the k is going to stay there, and now I just got to solve for k. So negative 1 cubed is negative 1. That's a negative 1k minus 3. Combine like terms. We get negative 1k minus 4 is 0. Add the k to both sides, and k equals negative 4. Number 6, is negative 3 a root of the function? Explain. All right, so they're telling us negative 3 is the root, so we don't need to change the sign because they didn't give us the factor. So we take that negative 3 and plug it in. Negative 3 to the 4th minus 10, negative 3 squared minus 2 times negative 3 plus 4. And get the old calculator going. Negative 3 to the 4th. And I'm coming out with a 1. So you can say, no, negative 3 is not a root because when I plugged it in, I did not get a 0. In order to be a root, plug it in, you have to get a 0 because the y value of every root is 0. Alright, example 7. What's the remainder when you take that polynomial and divide it by this? You could go ahead and do the long division if you would like, but our hypothesized root is negative 2. So let's plug it in. And no matter what I get, when I plug it in, that would be the remainder had I done the long division. Alright, so again, type it in your trusty calculator. And I got negative 9. So if you had gone through and done the long division using x plus 2, your remainder would have ended up being a negative 9, but we just found it a whole lot faster by the remainder theorem. So the remainder theorem says you plug in the hypothesized root and into the function, and it will tell you what your remainder would be if you did the whole division problem. Alright, some more of the story. When you plug in your hypothesized root, if you get a 0, that means what they asked you to divide by is a factor, and that the opposite of that would be your root. Otherwise, whatever you get is the remainder if you were actually to divide that problem. Good luck on the homework.